I think I'm live. Can someone in the chat confirm if that is the case, and also let me know if my volume is loud enough? Yes, no, maybe so. Well, I'm just going to, I guess actually I can check myself if this is picking up volume. Actually, I guess I have to do it over here. Testing. All right, this seems to be working. So hopefully this is going to be a short stream. Let me know if there's issues. I will try and fix them as they come up. But basically, I got a issue from Sahil, if I'm pronouncing that correctly, that pointed out that back when I was doing the combinatory logic live streams, which I actually don't know, when did 2 months ago? So what is it, May 26th today? Was the last time I worked on this. I had left a comment that said, if we zoom in on this, when GCC 13 comes out, replace this with the following. So this could be literally a 15 or 30-minute stream if I can get this working quickly. But I basically just wanted to follow up on this because GCC 13.1 is out. If we go to the GCC website, you can see that on April 26th, GCC 13 was released, which for our purposes is very exciting because that means that all the range adapters that are coming in C++ 23. So if we go to C++ compiler support, why Coke 0? I actually do have Bubbly I could go get, but I have unfortunately, I like Coke 0. There's 4 different carcinogens in it and phosphoric acid. I do not recommend that you drink Coke 0, but yeah. And then T Hill saying, in the famous words, if I can do this quickly. But yeah, we go to this compiler support. For those of you that don't know this website, it basically enumerates all of the library and language features coming in different C++ versions. And in the C++ 23 library section, if we search for views : if I can type correctly, you can see that, let me zoom in a tiny bit more. We've got zip transform, adjacent transform. If we go next, we've got join with, we've got chunk, we've got slide, we've got chunk by, we've got stride. I always forget about stride. We've got Cartesian product. That one's less interesting. We've got repeat. We've got enumerate. I forgot that got in at the very last second. And some different changes. So the point is, there are a bunch of different range adapters that are enhancing the C++ 20 ranges that came in C++ 20, obviously. And we can now go and clean up some code. And so the goal of this live stream is literally just to close this issue. So yeah, if you ever want me to do something, opening an issue about something that I said I'd do in the past is a good way to get me to do it. And thank you, Arslan, for the compliment. Caden's saying, my father has an old Turbo C++ book from about 25 years ago. That's a long time ago. I was just a baby back then. Anyways, first things first, let's see if this even compiles still. It's not what I wanted. All right, so it looks like it compiles. So let's just see if we go to our CMake. I mean, this is commented out. So let's actually just borrow a CMake command from a different project I was using. So actually, we will copy and paste. What is the build file? Do we have a building file? Let's go back here. We do not have a building.md. Let's go create one of those first. Actually, let's do this first. Look at that. Let's just double check that worked. Actually, let's clear the CMake cache and try that again. So yeah, we picked up 13.1. It's building format library. Okay. So I'm pretty sure this is because we're using werror. Victor, go fix your format library. Victor is the individual that. So we're commenting that out. Yeah, so this is not an error from my code. It's an error from the format library code. And which code? Everyone asks me about my keyboard. Let's go find it again. Amazon. What is this? This is a Logitech RGB. I don't know, mechanical something. I think it's this one. It doesn't look. I don't know. It's not this one. Sorry. Where's the back button? Yeah, it's this one. Yeah, except you have to. I mean, every keyboard manufacturer that makes mechanical keyboards calls these things different, like red, blue, brown. Logitech calls it clicky, linear, tactile. I actually don't even know which one I have. I think I have linear. The best thing I can recommend is find like your local Best Buy or whatever retail store sells all versions and just go try which one you like because they have different profiles. But yeah, if you're interested in the keyboard, that's the one I use. Anyway, so we're now building this with C++, but I said we were going to go C++ 23. And actually, are we building it with C++ 23? We need to go... We actually are. We already had this at 23. First things first, though, let's... building.md. And let me go copy and paste something from another project. You can't see this. I'm doing this off screen. Basically this here. So, courtesy of Matt Gobbold. Oh, there's a typo there. In Compiler Explorer, you can just go download this tarball, unpack it, and then set these library commands. And then this should work for you. So we'll just get C++ 23 with GCC 13.1 working. All right, we're good to go. Space Wolf says, "Are you Canadian? Greetings from Edmonton, Alberta." Yes, I am Canadian. I was born in Prince George, British Columbia, which potentially Space Wolf knows where that is, but nobody else does. I studied in Vancouver, and now I live in Toronto, Canada. Tien is saying, if you're using Ubuntu 22.04 or 23.04, you can do a get GCC 13. Maybe that's true now, but I tried to get this working like the day after or 2 days after GCC 13 was released, and they definitely didn't have like the backend repos updated. Anyways, well, we're at 13 minutes now. Let's go to the code and just see if we can make this work now. So let's zoom out a bit. So here we're basically trying to replace this inner product, which, what are we doing here? We are zipping together two sequences. One of them was clearly a flag, and then if the flag is true, we are keeping that. Yeah, so that's pretty straightforward. So basically what we have here is we're gonna have A, B, C, D, E, and then we're also gonna have a mask, something like this. And then the goal is to end up with a string that basically just keeps everything that corresponds to a 1, or a true in this case. So we're basically, this is like a classic pattern where you have some source string, and then you're building a mask that consists of 1s and 0s, and you're doing like a copy if, but the copy if is dependent on an alternative range. So actually there is we can do a little digression here. Where did this go? In thrust, there is a copy if overload. So thrust is a parallel algorithms library similar to the standard algorithms that you can find in C++. And you can see here that this doesn't exist in standard C++, but there's an overload that takes 2 input sequences. So this is like your first input sequence that you're copying from, and then there's a second input sequence called a stencil, which basically a stencil is the sequence that the predicate is performed on, but the copy is performed on the first sequence, if that makes sense. So typically in a copy if, in standard C++, you just have a single input sequence, you apply the predicate to the input sequence, and then if it returns true, you copy those corresponding values. But in many cases, you want to do a copy based on the result of the predicate being applied to a different sequence. So that's basically what we're trying to do here. We want this overload of copy if, but there's no real way to do that in C++, so we make use of std inner product here. What's this theme? This theme is material theme, ocean high contrast, I believe. My 2 favorite themes are either material theme or Dracula, which you can probably see, I don't know, somewhere in here. But anyways, this is my preferred theme at the moment. Anyways, that's what we're doing here. Let's see if we can just, odds are this code doesn't actually work. So I already know immediately that this doesn't work because ranges 2 did not get into C++23 yet. So the first thing we're going to need, we already have ranges, but we're also going to need, ooh, do we not have range v3? I do not want to have to pull range v3 into this, but we might have to. Yeah, that's irritating. So, I mean, we can just compile it and see what error we get. probably easier than me just guessing, but this conversion function does not exist in C++ 23 with GCC 13. This does, and this does, but not this. So let's just see what happens when we compile this. What the heck? Whoops. Oh, actually, yeah. And let's do this. In order to get this to format the way I like it to, you have to put comments after every single one of these lines. And once again, it's, yeah. What is this here? So there's a syntax problem here, but then also ranges 2. Man, it's really irritating that this warning is coming from format. What can you do though? Yeah, so now it's just complaining about this. So, I mean, this is kind of disappointing. We're going to have to go and use ranges just for this one function. But that's not a big deal. Let's just go copy and paste this range v3 code. And we're going to need to add range v3 in the target link libraries. Oh, look at that. So I already commented out. Look at that. Future me knew I would need it. And now we need to go back to our source code. And this is going to be in the ranges namespace. And this is going to be in range slash v3 slash range slash conversion.hpp. I think. That's kind of a guess. Now it's going to go pick up range v3. It's going to go and compile it. And I think the mask, does mask not work with the pipe operator? That'd be tragic if it didn't. God damn. I think I went too far. That was the error we saw before. I mean, this is not a good advertisement for C++ 23 because these are pretty gnarly error messages. Yeah, yeah, Joao, this is pretty bad. So I'm concerned actually that it's saying that there's no match for the operator pipe. The operand types are filter view of a zip view of a ref view to a string with allocator blah blah blah. Nobody cares. And then a ranges detail 2 container. So it's actually, it wasn't complaining about, this is fine. So I was correct. So like zip transform doesn't have support because it's a variadic range adapter that takes more than just the sequences as variadic arguments. But it works with zip. But it's upset that this doesn't work, or it's upset. It doesn't want to mix. Well, I'm actually not convinced. Let's just keep this. Well, actually, let's try something. So namespace view equals ranges views. I might want to grow a mustache. Why is that? Because I'm from Prince George? I can't grow facial hair, unfortunately. We've tried and failed. And we want filter.hpp. We want zip.hpp. And let's see if that works. What was it up to? Oh, I got the wrong. Why is it upset? Which standard library do I use in CMake? I use this one here, library path. So I think this is the equivalent of libstd C++, the one that comes with GCC. When C++ 23 fails, we take everything from ranges C3. I'm actually pretty confident at this point this will work. For some reason, though, it's not happy about this. It's not abundantly clear to me why at the moment. I'm pretty sure you can ranges to a. I mean, is this a, yeah, this function doesn't return anything, right? So let's, for the moment, comment out all of this stuff. A, B, C, D, E, and All right, so this built. Okay, so, I mean, this is what we expect. So, ranges to stood string. It is just, it's not happy about this. So this is the actual error. No match for operator pipe to filter view, zip view, ref view, basic string, allocator, blah, blah, blah. An unresolved overloaded function type. Okay, so I'm pretty sure, actually let me just go check my other repo to make sure that when you call ranges 2, it wants the okay, well I actually don't use it in that repo. Okay, so it definitely wants the parens. Ranges 2 container. Try the output as the first argument. Sure. Not a bad suggestion. This stream has turned into Connor parsing the god-awful error messages of C++, which supposedly in C++ 20, we're supposed to get better with concepts. I wonder if I mean, that didn't help. Well, well, well. So it doesn't mind stood vector. But it does not like stood string. I mean, do I need a string? Oh. Oh, does anybody see the problem? I just assumed the code I wrote previously was correct. I have now seen the problem. Admittedly, the error messages were absolutely no help. Maybe they were if I was a better error message reader, but here's a hint. The hint is that there is something that needs to go here, and we can get rid of all this stuff now. Boop, 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 boop. We can get rid of this, and I'm pretty confident we can get rid of this. So we can change this back to std string, and we can change this back to mask std views std views, and there's something that goes here that I forgot. I'll give it a few more seconds. Actually, I'll give one more hint. At this point in time, this is what we have. So the question is this convertible to a string? And the answer is definitely no. So really what we want, one way to do this is actually not with a std filter, yeah. It's with a transform where we are discarding the mask, the flag, and just keeping the characters. And actually, so if we just do this in steps, now when we compile this, what's it whining about? Line 173. Right, this needs a pipe as well. Transform. And maybe I was wrong about this. I got overly eager. Huh. So it turns out all variadic things. So this is what we want, and now if we run this executable, now we have just characters, which is pretty sad actually that I did not notice that for a while. So now if we do this toString and we build ranges has not been declared. We got rid of one too many header range /v3/range/conversion. And I think I need to go put back the parens. I do not need to put back the parens. And now we have the strings that we want. However, there's a nice fix, a nice optimization that we can do, if anybody knows what it is. And that's that there is a single range adapter that does exactly this transform. Anybody knows what it is? There's actually two. So the generic version is called elements. And I believe, I think that'll work. Or you need to leave off the parens. So yeah, that's one optimization, but there's even a further optimization, and that's that elements 0 is called keys, and elements 1 is called values. So I can just put values here, and we're good to go. I actually don't like the name values because it kind of implies that you're using like a hash map or a map or something like that, which we are not. But it is what it is. It's the name we've got. So that's it basically. How long did that take? 37 minutes? I mean, considering we spent however many minutes debugging this, and I kind of hate this. Get yourself a Model M, says Bendine. No! Courier says, actually I might like a Model M, but aren't they like super expensive and hard to come by? I know you're stockpiling them, but I'm not. Courier says, C++ is so strange. I can write code for an hour without issues, but the moment I think I do something smart, like using a new feature, I waste an hour making things work. Yeah. Joao says Model M. The Model M keyboard is like a famous keyboard from, I want to say, like the 80s. Apparently they're like industrial grade, like military grade. They never break. And Eric Niebler, when he was on the podcast, plug for my podcast, Eric Niebler was on, and he told this story of basically how when the pandemic hit, he was working at Facebook, and he left his Model M keyboard at work, and when he came back, it was gone. Or maybe he switched jobs during the pandemic and then basically never saw the keyboard again. But like, long story short, his manager or someone he worked with actually like had it, and they shipped it to him, so he got his keyboard back. Anyways, so we have successfully only took 25 minutes more than it should have. And I think actually, so let's go. And uncomment this stuff. Just to make sure this all still works. And I kind of want to, maybe we'll spend the last 20 minutes, because the goal of this was to be an hour, and then I would just fill the time with other stuff once I was done. Once again, if you just tuned in, these errors are not from my library. It's from the format library. Woohoo! So yeah, let's make that a single commit, or 2 commits. Git Jesus, can't type. Add range v3 for ranges 2, and then I commented out too much stuff. So this is clearly a debugging thing, and delete this, save this. And I think this is going to run forever. Is that supposed to print that stuff out though? Do I have an extra? I do have an extra format statement in there. I mean, that's a pretty nice. Should we create a pull request just so we can isolate this change? Call this refactor. git add git commit refactor using C++ 23 ranges in GCC 13.1. And then now we can although, because this is mine, I have to go to this one, compare and pull. What? Oh, because I technically wanted this to be in a different, but that's fine. Oh yeah, have I not linked this? This is all open source, and I believe I put it under some MIT license or something. Yeah, it's under MIT license. So refactor C++. And then we say fixes this. Is that myself? Yeah, it doesn't really matter. And then I guess if I zoom out, doesn't this look pretty? Very nice. Except, note, this caused us 25 minutes of debugging hell. And now I can just merge it. Unless if some, well, I guess people don't have the ability to go and review it. But we merge it. And now if we go to issues, there are none. Woo! All right, how much time in the stream? We've got 15 minutes. What I want to do in the last 15 minutes is, like, this kind of irritates me. Although, yeah, let's see if we can. Mohammed's asking, did you use any add-ons, plugins, and/or API libraries? I don't really know what that question means. I mean, I'm depending on a couple things in CMake. Yeah, let's go to build. Let's go to dependencies. Let's go to Blackbird, source, and let's open this. Let's see. Look at that. I already have them. Never mind. So let's just, and I've already got the combinators library here. Isn't that wonderful? Am I actually using any combinators? I guess it's hard to tell because they're, so we can scan quickly. Oh yeah, we're using the phi combinator here. We're using my shortcut for OR. The psi combinator, eq. Okay, yeah, so they're all over the place. So this should be, I'll just comment this out. Why did that? What the heck? Why is this one interesting? Anyways, was confused on the formatting of that. So this is the B combinator of eq1 and first. Right? I'll be kind of surprised if this works. Look at that, folks. Look at that. Oh my goodness. Actually, let's just compare. Let's compare. Everything starting there to here. I mean, should I explain that? Or should I just like let the mystery? I'll explain it. So let's delete a few of this. So basically, we're doing three things here. We are accessing the first element of this two-tuple, and I guess we're doing two things. We're accessing the first element of this pair, this two-tuple, and then we're checking equality with 1. So first is my shortcut for doing this, and eq1 is my shortcut for doing this. And then the third thing that we're doing that's kind of implicit in this code is we are composing these two operations. So first we're doing our access of the first element of our two-tuple, and then we're comparing it with 1 and checking for equality. And so although it's kind of implicit here when we're using these combinators, we need to spell that composition pattern. And combining two unary functions in sequence is the B combinator. That's my explanation. And that's why everybody should love combinators. Look at how, and look, isn't that just so much more beautiful compared to having that ugly bracket, bracket, paren, paren, brace, brace, semicolon, lambda? Just so beautiful. Yeah, Ben asks, ranges 2 isn't implemented yet in libstd C++, but it is in 23. Yes, so yeah, that is entirely correct. GCC 13.1 doesn't have it, but it did get into, in fact, we can actually just go prove that if we look for ranges 2. It's here, and it's currently not implemented, but it is in C++ 23 library features. So once, you know, GCC 13.2 or 3 comes out and it has support for ranges 2, we can then go delete the dependency on range v3, because that's the only thing we're using it for currently. And what does refactoring mean? Refactoring means just rewriting your code for the purpose of something. Typically, it's to make it cleaner and more readable. At least that's what we're doing in this case. There are other purposes you might be refactoring your code, but if we go to the pull request that we just did, and we look at this, and we go to changes, this was the previous code, which in my opinion is pretty awful. In terms of we're using this very non-generically named function that would be better named as like a zip reduce or something like that, to perform a basically compaction of a string based on a mask. And although you can use inner product for this, it just isn't, it's not that ideal. Whereas now in C++ 23, you can actually explicitly just do the zip from what I think this should be called, zip reduce, and then do your filter, which is the compactions, throw away the flags, and then convert this to a string. And I think this is undeniably much more readable than what we had here. Although I'm sure there's some people that would find some way to argue with me about that. Yeah, Aaron, if I'm pronouncing that correctly, says no new features, same functionality, different code. Yep, and now we've got 8 minutes. Let's go not create a pull request for this, but just commit this. Although, which branch are we on next still? Git checkout main. Really? There we go. Beautiful. Refactor using the combinator. Actually, let's put a little emoji. You know what? I hate Windows. Absolutely hate Windows. But the one thing, and I'm sure there's some little downloadable thing that you can do, but the one thing that I do like about Windows 11 is that you can go Windows : I think, and then get access to your emojis. Apps like WhatsApp and Slack have this built in with the : feature, but having access to it globally is very nice. Very nice. Mac has a single button for that. Yeah, I wouldn't be surprised that Mac has support for that. All right, well, we've got 8 minutes left. Oh, you know what? Can we do that? What the heck? Oh, we're going to be modifying this anyways, so it can't be const. Right? Yeah, next permutation. Oh well. Shiraz says, I use Linux. Yes, everybody should use Linux. It's the best. Joao says, solve a leak code using BQM. Sure, why not? You know what? Let's not do leak code though, because I already looked at the leak code problems this week. Let's do Perl Weekly Challenge. I haven't looked at this yet. We might not actually solve it if I don't like the problem, because I've only got 4 minutes left now. So leak code questions I check weekly, and then this one I don't check every week. But let's see. You're given a list of 3 or more integers. Write a script to find the 3 integers whose product is the maximum and return it. Sure. I mean, if these are all positive, that's pretty straightforward. So obviously you want to avoid zeros. What are the thing about this one though is they give you no constraints, right? You're at least given 3 or more. I mean, the naive way to do this is to just let's read the second one too. The naive way to do this though is to just check every single possible combination. And if you had less than like 150 elements or something, that'd run real quick. This one's a matrix thing though. So you're given a binary matrix m by m having ones and zeros. You're allowed to make as many moves as you would to get the highest score. To get the score, convert the each row. I think that's a grammatical mistake. Convert each row binary to decimal and then return the sum. Interesting. That one would actually be you're allowed to make in a row or column. I was going to say, don't you just flip the whole thing to ones? But it's not on a element by element basis. It's on a row or column basis. Okay, that one's too involved. We're not going to do that one. Although we could just do a variant of this, which just like calculate the sum. Yeah, so Aaron says take the top 3. This is for this problem. That's not as simple as that, because if you sort it, like this solution, you're actually taking the smallest 2 and then the largest positive number, because if you have 2 negatives where the product of those 2 negatives is larger than the product of the 2 positive numbers, you're always going to want to do that. So it's like take the top 3, but you also have to check the bottom 2 negatives. You also have to try and avoid zeros when possible. So like in this case, you just take the 3. In this case, you check is there at least 2 negatives. There's not, you just take the top 3. In this case, you check is there at least 2 negatives. There's not, so you just take the top 3. And I guess, yeah, you're always going to take the top 3, even if it includes 0, because 1 negative. Actually, that's not true. If your top 2 are, actually no, that algorithm would still work, because if you have like 10, 0, you're going to 0 out, and then you're going to end up taking the negatives as well anyways. I mean, we can solve this one fully, but first let's do this one because it's going to be cute. Yeah, we could do a stood partition. I mean, this problem actually isn't the best for BQN, but let's do. Let me open up APL. And so it's what is this? This is a 3x4 reshape 0, 0, 1, 1, 1, 1, 0, 1, 0, and 1, 1, 0, 0. So that's our matrix. Let's just call this mat for short, and then scroll up to give ourselves more room. So, and if we turn boxing on, so we turn our matrix, this is just for simplicity, and then now we're going to write a function that basically just converts each of these into decimal. So I can never really remember off the top of my head how to do this, but it's just the inverse, I think. I might have to go look this up if I can't figure out the right spelling. Something like that, though. Is that right? This is 3. This is 8 plus 2 is 10. And this is 8 plus 4 is 12. That's right, right? Someone spot check me on that. And then we just add these up. So, I mean, that's pretty fire. So basically, like, this is, I can never remember. These are like encode and decode. And it's for basically turning a series of, so like the classic way that you use this is if you have 1, 2, 3, and then I can never remember exactly how you use these. Yeah, so this like will take an array and then encode it using a base into a number. So it's like a way to go from like a vector of scalars into a scalar number. But the cool thing is that you can combine this with inverse to do the same. You can like go backwards, I think. Why did that not just work? Oh, right, because I'm not using the power function anymore. So like you can then split a scalar into its decimal values, and you can do the same thing with binary. You can switch like a mask of zeros and ones, and what we're doing is basically essentially that, right? We're taking each of these ones and zeros and then turning them into numbers. So pretty dope. Is there a way to improve this? I mean, can we do this? I'm not sure if we can do this like on rank 1. Definitely that didn't work. Oh man, that does work. Whew. So what is this problem called? Matrix score? So we're not really solving the full problem. The full problem is to perform some operations. And I think that works. So this says apply this operation on the left rank on the first rank, which is going to be row wise. So like take that function and apply it this way, I think. All right, there's a simplified version of the second problem. This one, so it's 312 4132 -1 0 1 3 1. And actually, should we do this one in BQN? Let's do this one in BQN. We did the first one. Let's finish typing this out though, and then BQN pad. BQM, the newest APL on the block. So we just actually, let's do this a different way. What's this one called? This one's called maximum product. Zoom out a little bit. Is this working? Is it just me or this is not showing anything? Oh yeah, live preview? There we go. Sorry, I'm not usually on Firefox. It's actually just to there's multiple different array little syntaxes. We'll use both just to demo the full language. We don't need to do the last one. All right, so I mean, what's the That's how you sort. And so, I mean, if we do a reverse sort and we do a 3 take, it's just the product of those 3, right? But that solution doesn't work all the time. And so actually, let's put in, so it's 6, 24, 3, 216. 6, 24, 3, 216. So I think actually the simplest solution is just to do 2 calculations and then the maximum. So in this case, it's what happened here? We're missing the take. Right, sort. So we're doing a reverse sort 3. So for the first 2 solutions, this works. And then we'll just do this verbosely. So if we just do x and max, so actually let's just do, like if we do a plus sum. Well, actually no. So the point is that we have our first answer, and then once this is a scalar, this will turn into a scalar max. So actually for now, let's do the concatenation. So you can, 6, 24. It's weird that it's at the end. But so now let's do a reverse sort as well. So actually, this is easier. Let's just do the alternative solution. And now what we want is a 1 take with a -2 take as well. -2 take as well. So compose that, and why doesn't that work? 1 take and that. Right, so now if we take the product of all of this, that should kind of work, but oh no, so yeah, this is actually, yeah, it is correct. I was thinking that we had the wrong answer for the third one, but that's definitely not the case. So this works. So basically we've got 2 different calculations. Take the smallest 2 and the largest and multiply those for 1 result. And otherwise just take the top 3. So just take the maximum of those 2 calculations, which we are almost doing here. So we just need to add this. We're going to simplify this in a sec. But so now we have our 2 calculations. The second number is just multiplication of the top 3. The first number is multiplication of the bottom 2 and the top 3. And in the cases where you have 2 large negative numbers, that'll work out, like in the 4th case. And so now we just replace this catenation with maximum, and then we have our correct answer. Now, here's when things get fun. So we already are using a fortran here. So this is a 1 take, a -2 take, combined with catenation. Is there actually a nicer way, if you've got 2 numbers? I think that's the nicest way to do it. You got 2 numbers on the left, 1 number on the right, and you want to multiply all 3. The only way to do that is to join them and then multiply them all. But note we have a sort here twice, so we shouldn't do that. So let's see if we can so now it's point free. I think we can remove one character by using nothing and no, I don't think that works. Because we're performing the sort before we pass it to both operations. Oh, this might be, note here we're doing a take twice. Well, we're now 15 minutes over my desired time. I also have not been paying attention to if I was off camera or on camera the whole time. I apologize if, not that anyone really cares that much. Can we... take out the reduction? Oh yeah, good point. We can't. We can't. I mean, we actually might be able to. So actually, let's comment this out for a sec and see if this works. So if we take this out, then we can actually take this out, and we can take this out. You might be right, actually. And then this is the psi combinator. Ooh, one character shorter. So now this is basically saying perform this operation and this operation on the sorted array, then multiply both of those before passing it to the binary max function. So that it is indeed one character shorter. I feel like there's a way, because like we have a redundant 2 characters here. That doesn't, there's no BQN programmers in the chat, is there? It's 30 people watching. Odds of that are slim to none. It would be really cool. Like, it would be really cool if you could do something like, actually, once again, let's, if you could turn this into an array, and then somehow repeatedly call this on your sorted vector. Except at that point, you would actually want I mean, let's see if we can do that, but like on a simpler example. So say we have 1, 2, actually let's just do a range of 5. And you want to, yeah, do a negative 2, and a negative 1 take. But you want to do this repeatedly. So that's the same thing if we put this in parens. So what if we then go I think let's go back to APL. I think I actually know how to do this in APL. So if we that's just a 2 take. But if we enclose this and we do that, and if we have negative and 1, yeah. So this is the pattern is you each your binary operation and enclose your right argument. So we each our binary operation, and what is the equivalent of enclosing? Oh, it works. But we're going to have to ravel it, which I don't think will actually save us anything at the end of the day. So we once again do this. So I was close. We do this and then we have to ravel this, which is the same number of characters, right? But it looks cooler. But this is, that was the goal, right? Removing the redundant take. Although, I think this is going to be a lot more, actually, I don't know. Probably it'll be roughly the same. Anyways, Nikolai saying, in C++ we could use 2 nth element calls to find the first 2 min negatives and 3 max positives. Yes. Actually, do you even need nth element? Yeah, I guess actually nth element is probably the best choice. It's the best time complexity. But I mean, like, it might just be easier to do, depending on the size of your data, 3 repeated calls to, actually, I guess for the top 3. Yeah, probably. Five nth elements should be faster than 1 sort. Yeah. Yeah, probably. All right, that's where we're going to end it, folks. We went over by 22 minutes because Joao nerd sniped me into doing some array programming. Yes, and Amato points out same number of characters, but now they look cooler. I think this does definitely does look cooler. Anyways, thanks for tuning in. Hope you enjoyed. If you came for the C++ and stayed for the array language stuff, thanks for staying. And maybe we'll do another one of these live streams. Actually, probably not recently because I'm traveling for the next month to different conferences. If you're going to be at Lambda Days in Krakow, Poland, Italian C++ in Rome, Italy, or C++ on C in Folkestone, or CPP North in Toronto, which is where I currently am. That's in July, though. Come by, say hi, and yeah, maybe I'll meet a few of you at one of those conferences. All right, thanks for tuning in, and we'll chat with you guys in the next live stream, whenever that is.